This rain deposited radioactive material on the surface of the water. Six days after detonation, extremely high radioactivity was reported in the layer of mud and sand on the bottom. Diffusion and convection currents had done their work. Radioactivity would have brought death to thousands of men if personnel had been exposed on the target ships. At 1,000 yards, topside personnel would receive fatal doses within 1 minute. If their ships were immobile or contaminated, they would receive 20 times the lethal dose within an hour. These are grim facts. Topside personnel within 1,700 yards upwind and 2,500 yards downwind would receive lethal doses within 5 minutes. If they sought shelter below decks, the dose would be reduced by more than 1/2, but survival would be a long chance only. Porous materials such as cordage, canvas, and wood were much more heavily contaminated than were metal surfaces. Ships with wooden decks absorbed much more radioactive rain than did ships with metal decks. Closed hatches and ventilators kept much radioactive material from penetrating the interiors of target vessels. When leakage did occur, decontamination problems were serious. Certain below-deck areas on the Salt Lake City read as high as 20 Röntgens per 24 hours, 13 days after the blast. Similar below-deck conditions existed on other vessels because radioactive water had entered through openings resulting from Able Day damage. Submarines being submerged were not subjected to the radioactive rain, so contamination was less than with surface vessels. Bitumastic applied to submarine hulls showed a particular affinity for radioactive products. Decontamination of this porous material, when necessary, was difficult. Target vessels were not alone in exposure to radioactivity. Support ships operating in the lagoon began collecting deposits of radioactive material in their evaporators and saltwater lines. Removal of these deposits presented serious problems, and crew activity had to be carefully monitored. Marine growth and rust spots also favored accumulation of fission products. This situation posed a separate problem requiring attention upon return of the ships to major ports. Fewer animals were exposed in Test Baker, but results were even more striking. Virtually all of the Test Baker animals were dead by 1 November 1946, victims in most cases of gamma radiation. No animals were exposed topside. The animals were placed in the sick bay operating rooms on 4 APAs, the Gasconade, the Briscoe, the Catron, and the Bracken. Death of pigs and rats on the Gasconade, Briscoe, and Catron was caused by gamma radiation which passed through the metal of the decks and bulkheads after emanating from contaminated material which surrounded these vessels. When recovered, the more heavily irradiated animals were already in a dying state, capable of only feeble muscular activity. Others suffered from diarrhea and extensive hemorrhage into the skin and other tissues. Although the greatest amount of shock from the Baker blast was transmitted through the water, the shock wave in the air was equivalent to that from an explosion of 4,000 tons of TNT. Through instrumentation, scientists confirmed that the peak pressure in the water at close distances was greater halfway between the surface and the bottom than it was just beneath the surface. The positive pressure in the water, a tremendous hammer blow against the hulls, lasted for about 2 milliseconds. The negative phases and reflected pulses followed. Underwater pressure was irregular because of different angles of reflection from the bottom of the lagoon. As quickly as possible after Baker Day, technical and scientific groups made their inspections, gathered up their test materials, instruments, and data, and returned to the United States. General homeward movement of the task force soon left only skeleton logistic detachments and radiological survey teams behind. By September 26, 1946, Bikini Atoll was completely evacuated. Entry of unauthorized shipping to the lagoon is still restricted. Many of the target ships remained at Kwajalein for further radiological study. All ships of the supporting force were carefully monitored when they arrived at United States ports. Those that showed residual radioactivity were decontaminated. At the Joint Task Force headquarters in Washington, work of preparing the General Joint Task Force report and more detailed unit reports was accomplished. Scientific analysis was initiated at military installations, universities, technological institutes, and research laboratories throughout the country. Obviously, only data which could quickly be extracted and readily be analyzed could be included in the preliminary reports. But even these soon grew into 30,000 pages of technical matter. They are still growing. Complete evaluation and correlation of significant information will require years. Some results had an immediate practical application. Some groups will continue to be interested in dynamic effects of the explosion, the ship, water, and air motions and their consequences, radiation, shock pressures, displacements, stresses, and distortions. Other groups are concerned with measurement of physical change wrought on materials. These changes include transformations in solid structures, loss of strength, metallurgical effects, absorption of radioactivity, and decline of corrosion resistance or durability. During July and August 1947, a year after the Able and Baker explosions, a comprehensive resurvey was made of Bikini Lagoon. Studies were made of residual radiation, particularly in food organisms. Great attention was given to dangers from alpha radiation. New biological specimens were taken both from the islands and from the surrounding reefs and waters. Deep cores were drilled into the coral to determine atomic effects upon reef-building processes. These cores went almost twice as deep as previous drilling in a Pacific atoll. Divers raised important instruments that could not be previously recovered. The sunken Arkansas, Saratoga, Nagato, Pilotfish, Gilliam, and Apagon were of revived interest. Examination was also made of a portion of the LSM-60. Scientists were particularly interested in types of rupture, heat effects, and radioactivity. For the first time, underwater television was put to scientific use. An underwater camera was lowered over the submarine Apagon, lying in about 160 feet of water. While no new data was obtained by this experiment, the test pointed the way to interesting developments.